I want to talk about loosely or lousily coupled architectures. Just a housekeeping rule. Okay, this is recorded, so you will get a recording later on as well. The slides will be available. If you have any questions, if this is a super urgent thing, you can always try to interrupt me. You can put it in the chat. I have the chat on the second monitor. I'm not 100% sure if I will see everything, but I reserve time at the end for a Q&A, so don't worry. Yeah, in that sense, good morning, everybody. Good evening, depending on where you are. I heard we have people from all over the world. That's pretty exciting. Might be very early for some of you. So I'm happy to have you. In order to talk about loosely or lousily coupled architectures, I thought we have to talk about food first. So I made good experiences with making food examples for a lot of metaphors, basically, for a lot of concepts and idea around IT. So I just wanted to continue that. So, and I'm sorry if I start that directly after breakfast. You have to hear about pizza. So I have coffee as well later on. Don't worry. So if you want to order pizza, and there are a lot of ways to do that. If you live in a, let's say, a rather small town like me, the way you do that is normally you call a pizza place. And it's really like that. I still call pizza places with the phone. If I use the phone, that's a very synchronous blocking communication. And basically means I'm at the phone. I can't do anything else than simply waiting for a response, right? So it's blocking me, right? But I might get a feedback loop directly afterwards. So it basically means I have somebody else on the other side of the phone. So that means I get some feedback. Hey, we do the pizza. Hey, we can't do any pizzas anymore. Or hey, it will take 2 hours because we're so busy, right? So I'm getting a feedback loop, which normally makes me feel happy in that case. I don't feel forgotten. But I'm coupled with the other service, with the pizza place in this case. We will talk about different ways of coupling or different types of coupling later on. And this is temporal coupling. So I'm really bound to, hey, is the other peer, is it available? They might have closed at the moment. They might be busy. They're answering a lot of phone calls, so they can't pick up mine. And all of that means I can't get through. I have to retry that. I have to wait probably for half an hour for them to open, to call again, or if it's busy, I need to call again in a minute and try it a couple of times. And I'm pretty sure you know all of that from like daily life of calling people with a phone, right? That's temporal coupling. You could send an email, right? So you could send an email to your favorite pizza place. Hey, I want to order this pizza. That's asynchronous non-blocking communication because you added that queue in between, right? And the queue in this case is an email inbox, but in real enterprise use cases in software, that's typically like messaging system, NQP or whatever, or Kafka or whatever, right? It's non-blocking because you're just sending the email and then you're free to do whatever you want to do. You don't have to wait for the feedback or anything. You just send it off. And there's no temporal coupling because if the other side is not open yet, the email is waiting there until they open, then they get the email and then they can start processing it. So you don't have to retry. You're pretty sure it's in the queue and you're done, okay? But it doesn't have a feedback loop. And especially with that example, you can think about sending an email to your pizza place. How do you feel? You're more confident than I am, but it's like, did they get my order? I have no idea. It doesn't let me feel relaxed, right? So you could get a feedback, like you could add a feedback loop. Basically, that's normally the response email, like they are answering, hey, we got your email, pizza will be delivered in whatever half an hour, right? Then you get, again, the feedback, but it's a separate message technically, okay? That's a feedback loop. We will come back to that a little bit later, but the feedback loop is not the result. If I order a pizza, I don't want to have the acknowledge that I get a pizza later. I want to have the pizza, right? And that's a different thing. Feedback versus the result. We will see later on for certain communication patterns that this distinction is pretty important. And yeah, and I think it's pretty obvious as well, but sometimes it helps to bring it up to cautiousness about that. You can make other examples, and I love this. if you look at that, it's also very obvious, but we all know it from real life. So if you go, and this is in Germany, if you go in Germany to a small bakery, this is how it probably looks like. You're going in there, there's one person behind the counter. And if you order something, it basically means they turn around, get everything together, take the cash, and so on and so forth. They finish that off for you at all. It's synchronous and blocking because it means that person is really exclusively working for you at the moment, and you're blocked because you're waiting for your things to get back. You can't do anything else in between, right? So that's synchronous blocking behavior. And if you order coffee in these places, I mean, first of all, it's normally not good, but that's a different story. But if you order that, it also means a person turns around, go to that, for example, machine and gets a coffee, which normally takes at least, let's say, 20 seconds to do. You can do that. It's kind of a homework exercise. I did that the last time when we renovated the house here. I basically had a couple of people helping me. It was pre-COVID, so that was easy. And I went over to the bakery to get coffee. And I ordered whatever, 10 coffees. And you have a queue in behind. The people start hating you, right? Because you're blocking everything for quite a while. So the synchronous blocking behavior here for the result is basically, it's a bad user experience. It's not nice for me. It's not nice for all the other people waiting, and it doesn't scale. So if you have more and more people getting coffee, it simply doesn't scale. If you're looking at Starbucks, and I love this example, and Gregor Hoppe, I'm quite happy about this blog post. He did, I think, more than 10 years ago now, but it's a pretty good blog post, and he basically looks at how Starbucks is handling coffee orders, and it's very different. You go to the cashier, you basically order and you pay. That's a relatively short-lived thing. What do you do? It's very quick actually, and then they put your order into a queue. This is the only thing you do synchronous and blocking. Then you get kind of the feedback. Yes, we'll do your coffee, and then they put you in a queue, and then basically they have the baristas doing the coffee. They take the orders out of the queue, and you can scale the baristas independently. And you can see that if you have big Starbucks, they normally have probably still 2 cashiers, but they might have 3, 4, or probably even 5 people doing coffee, because that takes longer than taking the money. The side effect of that story good, and that's what, for example, I think McDonald's is doing that. As soon as you're there, you can automate the cashiers by providing that as an app. But that's when Starbucks started, that was not their intention. I think it's but it's a good example of if I separate these kind of different tasks properly, I might have more angle to automate certain things to make it more efficient. But that's a different story. I want to look at the scalability of that. And that at the very end, the coffee is put here, and basically then you get it from that queue. This is why they ask you for the name. That's a correlation identifier. So you get it back at the very end. They call for you, hey, coffee for, which is always funny for me. Bernd in English doesn't work. So I get very different names, but I get along, right? So this is a very scalable way of coffee making. And I started with pizza, and you can see the same patterns everywhere. So if you go, like, again, a small kebab place, at least here in Germany, if you go there and order pizza, it's almost synchronous blocking, right? But of course, you can do that much more scalable. So if you look at bigger pizza places, they might have a lot of queuing there, like for the orders, for doing the pizzas, for the oven, and so on and so forth. So that makes it more scalable. I think you got the idea. And it would be actually weird in this example to think of a synchronous blocking result, like calling the pizza place, and then you're on the line, blocked, waiting for some person, like knocking at your door, hey, here's your pizza. That would be synchronous, okay? Still, it's a very common behavior, and come back to that. But an important thought here is the task of pizza making is long running. And that's an important thing we have in the whole distributed systems world now, long running things. And that's probably a weird hobby of mine, but I very often think of things in terms of HTTP verbs, because somehow that makes sense in my mind. So and result, by the way, is an HTTP 200 response. So here's your result. What would make much more sense is actually just having the ordering step synchronous. and this is a typo on the slide. That might be normally HTTP 202. So order accepted, hey, we got it, we come back to you, right? But then the response, then you put in a queue, then you probably are in a couple of queues until it's really in the oven for some time, and then you get the pizza, right? So this is totally asynchronous. And this pattern, independent of any pizza, it's actually very common. So we see that all over the place. If you do a microservice, if you do a service, very often you have kind of a synchronous facade here, at least to provide the feedback. Right? You can also do asynchronous stuff here, like messaging and message back, but behind the scenes, it's normally starting to get much more asynchronously. Cool. Just as a disclaimer, I said long running. Long running is my thing, so that's probably good to be aware of. So my name is Bernd Ruecker. I'm co-founder and chief technologist of Commanda. We're doing an open source process automation platform, and I'm in that whole scene for roughly 15 years now. I should calculate that correctly, but I'm working with a lot of, I contributed to a couple of open source workflow engines over that time. And yeah, I'm working with long running things for kind of all my life. And this still fascinates me a lot. And you should probably have that background to know my bias, which I might also sneak into these slides. But the more important thing probably, if you, there's my contact data. So if you want to reach out to me, always feel free to ping me on LinkedIn, to ping me on Twitter, tweet about the talk if you like it, and send me an email if you have any questions. Don't hesitate to, right? I'm super happy to discuss things. So always reach out. So long running, pizza making is long running. When I think of long running, I normally think of processes. I said that I'm kind of in the workflow engine field for long, and workflow engines are good at waiting. So basically you could express this task of pizza making by kind of a process where, for example, here you have to wait 10 minutes when the pizza is in the oven, and then notify somebody of taking it out. It works a little bit different in real life. I'm totally aware of that. We're trying to get to these subtle differences in a minute, but just as an idea. And my world is kind of where you have a tool like a workflow engine, it can keep state, and then it can run kind of such process models, probably inversion. You can react to something if it takes too long, and so on and so forth, in order to better implement this long-running behavior. It's not the focus of this talk, but it's kind of important for one or two thoughts later on, and it's kind of what I do every day. So I let it sneak in. Just to give you an idea how this could work. So you could have a bit of code where you say, hey, I kick off a new process instance. Then you have a new instance like in the database where you exactly know, okay, this follows this process model, and it's probably then going to this one task there. And there it has to wait, for example, for the credit card service to become available, right? For the pizza place to open up or whatever. So you can have this. It's persisted. How this is done exactly depends very much on the tool. So this is pseudocode, and it doesn't have to be a database like that. It's kind of the idea, the concept. And then you can attach more code where you say, okay, what does that mean exactly? How can I really do a REST call, for example? And this is, again, code. So if you're in Java, that might all be Spring Boot, for example. Okay, just to give you that idea. We need that later on. Just then you have it now. Cool. If you're looking at process engines or workflow engines, they basically provide two big values, or bring two big values to the table. One is visibility of these process models. So what happens in what sequence? Where am I in that one process instance? Something is stuck. Where is that? What are the next steps? And so on and so forth, that you can see this. The second is really the long running capabilities, which is basically state handling. I can remember, oh, this process was waiting there for getting the pizza in 10 minutes, and it's not yet there, so it can escalate, for example. I remember that. And now there are a lot of different use cases, actually. And one is really, and we come back to that later on, solving some challenges around remote communication and coupling. Right? That's the one thing we're talking about today, but there are others. which we don't tackle today. Transactions, one of my favorite ones, or like process orchestration, like the bigger business processes, integration patterns. Also, Krieger Hopi did a lot of things around that. And probably also graphical programming, but that's normally not where the sweet spot lies. So this is kind of a good context to know. But this is orchestration, right? Hey, a workflow engine, this process model, this is orchestrating things. Isn't that coupling anything much tighter? That's the thought or the idea I get, the sentiment, let's say, I get from a lot of people now. And let's look at that, because I find that a super interesting thing to explore. And get back to the pizza ordering, because we can do a lot there. So you could call the pizza place. I order this pizza. You get back the feedback. Okay, I got it. Right. We deliver the pizza. That's what's called a command. To send the command to the pizza place, which is the order of the pizza in a way. It has an intent. You want to have a pizza. It cannot be ignored, right? So if you call them and say, I ordered this pizza, they can't ignore that. It would be really weird if they just stay silent. I haven't heard anything. It's normally like they have to send you feedback. It doesn't mean they are forced to do it. They can reject it. They can say, we don't have any capacity to do more pizza, sorry, right? So it's not that they are obliged to do it, but it cannot be ignored. And it's totally independent of the communication channel. So you can send it as an email. You can use your smartphone app to order. You can call them. You could send them a letter, probably, or whatever, right? It's still a command. It's independent. That gets important in a second. The second possibility is like, there's something else you could do. You could use Twitter and tweet, hey, I'm hungry. That's an event, right? I'm saying, hey, I'm hungry. That's an event. It's a fact. It's something that is simply true, that just happened. And the idea behind events, and they're pretty famous now, is that the sender can't control, or shouldn't probably the sender cares, but it can control what happens. Okay, so in this example, it's really, I'm telling the world, hey, I'm hungry. And in this case, there's no contract somewhere that this leads to anything, right? So, I mean, I would be pretty lucky if I get a pizza in this case. You can also look at that more from the internal perspective, because that's external, right? And that's event-driven between organizations, companies, or customers and providers is very rare, actually. So let's look into the inside of it. Let's look into one pizza place doing the pizza. There you could also, again, work command-driven or event-driven. So if this person, which might be the owner of the pizza place, has this pizza ready, and I'm not 100% sure if this is really pizza salmon, but I thought it is. So he could say something like, pizza salmon is ready. That's an event, right? Something happened. It's a fact. But he could also say, oh, I'm the owner here. I know what I'm doing. So this is the pizza. I baked it for Andrea. Please package that in that carton and drive it over. Okay, that's a command. And the important thought here is not the either or the other way is right or wrong. It's just a different way of working here. It's something you have to agree on within that pizza place if you work the event-driven way for this situation or the command-driven way. But I find it, I'm probably it's because of my gray hairs, but I have so many discussions where during the discussion, you understand that people don't really have this difference present in their heads. So I find it important to understand that. So for me, or not for me, I think this is a really common definition. I have another definition in a minute, which might not be 100% common like this. But an event is something that happened in the past, a fact, sender does not know who picks it up. Command as a sender wants something to happen. It's an intent, right? But the recipient, that's different here. The recipient does not really know who issued the command, right? If you're in at least microservice communications. I have an example for that in a second. So I'm probably the last example with pizza, I promise, and then we move on. But if you look at like some restaurants, they work exactly like this, right? You get an order, then you get this, what's the English word for that? Like a ticket or whatever, like where it's basically said, okay, this is what they ordered. You put it really on a physical board. And that's kind of an event, right? Somebody ordered this. And then you have another person probably in the kitchen, and he looks at that board and like, oh, okay, I have to cook this and so on and so forth. And when he's ready, he basically puts it at the counter saying, okay, this is ready now. This is what's called a choreography, because it's basically just has a flow of events and there's nobody that really controls that kind of sequence. It might work very well. It really depends on the situation. What you can observe is that you don't have an overview of what's happening here. So if it takes longer, and probably the guest asked for his pizza or their pizza, yeah, you have to run around basically looking for where is that ticket now, what's currently happening. So there's not that point where you can look into what's the current status, right? It's also sometimes hard to change. So if you want to adjust the pizza baking process, you might have to talk to different people and understand how this is working. Again, in this case, it might still be super fine. But just to contrast that, for especially bigger kitchens, it very often doesn't work like that anymore. They have like an order man, like a small app here where they put in the order. And then you have really an orchestrator, like a small app, basically telling also the kitchen what they should do next, right? So and this orchestrator knows, okay, please do this. And then also the cook confirms what he already did. So the orchestrator knows what's happening and what's next and can inform the right people and so on and so forth. I know that this is in the restaurant example, it's kind of probably borderline what's better than the other. It really depends on how you work. I find the important thinking here, it's a difference, right? And it doesn't have to be the one or the other. It just needs to be aligned with how you want to work. Okay. For me, again, and this is probably more debatable, but I believe this definition makes a lot of sense because it's easy to understand and helpful. So orchestration for me means command-driven communication. Whenever I send a command to somebody else, I orchestrate that. Right? Choreography for me is event-driven communication. I react to an event. That's a choreography. Let's do a more business-alike example. Let's come back to microservices. So let's assume you build an order fulfillment applications system. So you're on whatever Zalando, for example, and you want to build your whole order fulfillment process. So you might have a couple of microservices doing certain things, and they might emit events like, hey, somebody ordered something, and then you can do a choreography if you like. So you could have a payment service listen to that saying, okay, new order, so I need to collect money. Hey, payment was received. So inventory could listen to that saying, payment was received. So let's get something from stock and so on and so forth. Right? So by having these events and these event subscriptions, you basically implement the overall business process. Right? My problem with that is that this is what I call an event chain, and basically it's invisible. It's nowhere explicit. So you can't see it by looking at certain components. It's pretty hard to figure out very often. So you might have to look at like all the services in order to really understand what they're listening to, or you might observe the system during runtime by looking at all the events and trying to figure something out from that. Right. So this is my big problem I have with this. It's also hard to change. I don't think I have the example in the slides today, but you can think about that. Hey, I want to fetch goods first before I receive payment. Hey, I want to reserve goods before I receive payment. As soon as you start making changes to the sequence of steps, it gets pretty hard to change because you have to touch multiple microservices exactly in terms of coupling what you don't want to do. And there are a lot of stories around that by now. There's a famous blog post from Martin Fowler, which you might find if you search for that. I love this one. It was at KubeCon New York 2019 from Phil Calzado. At that time, he worked at Meetup, and they were very event-driven. He said we were suffering from pinball machine architectures. Like you throw in the first event and it bounces through the system, and it's pretty hard to understand what just happens and why. Okay, so that's at least the risk. What's the alternative? The alternative is orchestration or more orchestration. And I always like starting this example by keeping one event, saying like, hey, order placed is still an event. So there is place for events. It simply means that what I said earlier on, the sender does not know what happens. So the checkout component is not responsible for order fulfillment. Their responsibility is to put the right event on for example, an event bus saying order placed. We're done. That's all what we have to do. If the order is not fulfilled, nobody will blame us, right? That's kind of the thinking behind the whole idea here. But order fulfillment is responsible for doing order fulfillment. So they need to pick up the event, and now they are in the lead of making sure that order is fulfilled. They're responsible to meet SLAs like, hey, every order should be fulfilled within whatever 24 hours. They have to make sure no order is dropped for whatever reason. If somebody wants to know certain status or statistics about orders or order processing time, for example, they go to order fulfillment. So it's really about responsibility, not so much about technical things, but really like, okay, there's this team which is behind the microservice that is really responsible. In order to be responsible, you have to be able to control certain things. It's quite weird. You're the person responsible, but you can't control anything. It emerges like there are events ping pong, but you're responsible. That's kind of weird. And I always also find that super naive if you're thinking of, we have Zalando as a customer, so they are doing order fulfillment with our platform, for example. It's quite strange to think of Zalando where their core business process is order fulfillment, thinking they let that emerge out of a couple of events. No, they want to have very good control over certain parts of the process. Other parts might be events, yeah, but this is the important decision. And it's a decision, it's nothing which is given like this is how it has to be. Anyway, now order fulfillment wants to control that. First, payment is retrieved. So it sends over a command to payment saying, hey, retrieve payment for me now. And then it might get back kind of a result, a feedback, or probably an event, hey, payment was received. All right, and then same for inventory and shipment. And now you have that place where you can really understand how the process is actually working. Now, this is a mixture. We have choreography as soon as it's event-driven. We have orchestration as soon as it's command-driven. This is kind of how I define things, which works pretty well. And that also means, and that's important, you can't say we build a choreographed microservice architecture. It's pure choreography. That normally never makes sense. As well as it's a pure orchestration also doesn't necessarily make sense. This is more common actually because the concept of events is still not present in a lot of architectures. But from my perspective, you normally need a clever mixture of both. That would be ideal. And second important thing, and now we make the link back to the beginning where I really emphasized on basic concepts. What's called the collaboration style, command versus event, choreography versus orchestration, is independent. It's totally a different thing than the communication style, synchronous or asynchronous communication. Do I send a named QP message or a Kafka record on REST call? That's two different questions. And this, I find this always mixed up. It's like, we're doing a REST call, you're orchestrating. We're doing MQP, this is choreography. And this is simply not true, right? You could say, okay, I use an event on Kafka, for example, for the events. Yeah, that's very common, but it could be a REST feed. Not that a lot of people are doing it, but technically it's still choreography and events. Right? I might use synchronous blocking REST calls because that's what I have for example, for existing services, but I can also use messages, right? So it's an independent decision. And I find this super important. This is why I'm so keen to look at that. If you're like me, you're probably, hey, slides are nice. Probably you're not even like that, but I think slides are nice sometimes. They give you a good idea, but if I want to dive deeper, I need code. So there's code available for exactly that example. It uses Kafka, Java, and Spring Boot and Camunda. Or does it even use Spring Boot? I think it was plain Java, actually, for most of the cases, in order to be as self-contained as possible. Anyhow, you can run that yourself. So that's all on GitHub, so you can play around with that. And there you get an idea of what it means, sending events around. And there are a lot of good questions around what data is in what event, what's the data flow, and so on and so forth. And it really helps to play around. That's what my impression of that. So this is the link to the code if you want to. Let's go one step further. And if you look in, for example, Sam Newman's book, Building Microservices, which would be a good idea. That's a pretty good book. I think he has a second edition out now, so probably look into the second edition, but anyhow. And he has that one example where he makes a case for event-driven architectures, where he say, hey, it might be better off if a customer service microservice, for example, just publishes a, hey, customer created event, and then other services can subscribe to that in order to, for example, add this new customer to the loyalty points bank. Instead of the customer service needs to know all these other services and orchestrate them to say, hey, we have a new customer. Okay, then I have to create the loyalty points bank entry and so on and so forth. Right? This is less coupled because the customer service doesn't have to know about that. And I do agree for this use case. But if you look at the overall customer onboarding process from, hey, there's a new customer, to it's totally created, you might have parts of that process where customer onboarding is responsible for carrying out. For example, that no customer is ever created where the address check has not happened. That might be a responsibility of onboarding. So you might want to orchestrate that, sending something like calling the address check, like probably a REST endpoint, or sending an MQP message. Again, I don't care about the technical thing here, but the important thing is I orchestrate the address check to know that as soon as I did address check, I can do, for example, the credit check, right? And then only then I create the customer. And then, and this is probably interesting as well, this is, you might have guessed it, orchestration. And then I might send out a welcome letter. And this is an interesting point. This could be done by events. I could publish the customer created event. And I do that here anyway, because I really think the loyalty points bank and the notification service is a good example of choreography, because I really don't want to care or think about that here. But the welcome letter really depends. I have that. I mean, if you know me, you probably know that. I always have this handy. It really depends. And in this case, it's a bit like we have financial customers, for example, or also in insurance, that's sometimes a problem or a thing where you have legal obligations to send certain letters. And you have to basically note that down. If you haven't sent that letter, you can get a problem, right? And then it's the responsibility of customer onboarding to really make a record of, we sent that letter, that was the exact date, here's the letter, and we send it. In this case, it's orchestration because you want to control it, right? It might be that it's simply, hey, we send you a welcome letter because we are nice and we want to do so. Then it might be choreography. It's really, a decision. That's an architecture decision you have to do. Okay, sorry, I'm always getting a bit heated up in that topic. I discussed it for so long. I have a whole talk on that. I've written a book that was published in beginning of the year. I can totally recommend that, but would be weird if not. But there's a whole chapter on choreography versus orchestration in it. If you go to the website of the book, by the way, which I've linked on the last slide, there's a free PDF electronic version available at the moment. So that way it's very easy to look into. Okay, anyhow, so communication style and collaboration style is not the same, right? This is important. And there you have examples like REST, synchronous blocking, command driven very often. Messaging is asynchronous, but can be it's normally a command, but if you use a topic, then it's event-driven, so on and so forth. Okay, you get the idea. Looking at the time, I want to move on because I have one other thought I want to get through. Coupling, that's actually the main topic of the talk. So let's go back to coupling. And I find it important that we differentiate 4 different types of coupling. And if you go to literature, there are actually a couple of different ways of phrasing that and a different number of. This is kind of in line with what Sam Newman also does, and which I think makes a lot of sense. So there is implementation coupling. This is the famous, I have a joint database, right? My 2 microservices have a joint database and they write and read from that, which normally means I'm probably looking in that one table of the other microservice because technically it's so easy. And that leads to all weird problems down the road because then you can't change one microservice anymore because you know that other are probably depending on certain implementation details, which is a really bad idea. I think that's clear. So that's the whole idea that comes with microservices. This is why a well-structured monolith, which could be a good idea, typically doesn't work that well because they're super easy to the implementation coupling creeps in without you knowing. This is why you want to separate them as much as possible to avoid this hard, like force to avoid this. Okay, the second is temporal coupling. We talked about that in length, right? Synchronous blocking communication typically has temporal coupling. And this is one of the areas whenever we talk about loosely coupled nowadays, it's most often refers to temporal coupling without anybody explicitly saying that. And we should reduce temporal coupling. Now people are typically saying we need to reduce coupling. Right? I agree with implementation coupling and probably temporal coupling, but you see that there are even others like deployment coupling. And that's a typical release train. Hey, we have to integrate all the components because we do one big fat release at once. Or you integrate a library, deploy together. It's deployment coupling. That's typically, you should avoid that to some extent, but it really depends. In some cases, it's also pretty neat to have it. With continuous delivery, sometimes it's not always super painful, right? And sometimes it's simply easy to do. So this is something you have probably to look at. The most important thought about coupling is that there is what's called domain coupling. So in our order fulfillment example, it means I don't want to ship orders that are not paid. This is a business requirement. It doesn't go away unless you change the business requirements, right? And this is important to acknowledge, right? This is not necessarily bad. It's something I want to have. And I can't, even if by using events, I don't remove it. It's still there. I can only remove it if I change the business requirements, okay? And that's important to acknowledge. And very often this gets mixed up. So when we say loosely coupled, typically we refer to these. I mean, removing domain coupling is sometimes a good idea and probably also something that's worth to discuss with business stakeholders. Can we remove that dependency there? Is that really important from a business standpoint? But it's nothing we can decide in the IT, right? Deployment implementation is typically easy, and temporal coupling is something, yeah, we probably should. But another thought, do I have a, yeah. So for temporal coupling, and I make this quick to be able that we still have a couple of questions, but reducing temporal coupling is very often, yeah, it's about, I mean, we're talking about two services communicating. I don't need this, but the typical solution is messaging for this. That's kind of seems to be the silver bullet, like, hey, I use messaging, I remove the temporal coupling. Yes, to some extent I agree, and I'm a big fan of messaging and asynchronous communication here, but I see a lot of teams struggling with it because they're not used to messaging, they don't have the complexity like really under control and so on and so forth. And I even get hints that I should go to the Q&A. I know, I'm on my way. But what I find important is that, and I actually learned that over the last, I would say 1, 2, or probably in 3 years, that there are now by now a lot of patterns. I don't go into that. That would be an own talk, like circuit breaker, for example. If you do REST calls, it can do a lot of great things for you. Retrying, or I also have ideas around stateful retrying, using something like a long-running capability like a workflow engine to wait for the other service to become available on the sending side and then retry. Of course, this can have issues around adding retries, adds load, probably you need back pressure. There's a lot of complexity in here. So again, that's an own talk, which would be a good talk actually. But what I'm trying to get at is that messaging is not the only way. And what I've seen is that a couple of teams, if they're not good in really managing messaging, they might be better off with simply, again, using REST, but know the right patterns to be able to handle that. And there are also long-running capabilities help you out quite a lot, actually. And yeah, there, if you look in the slides, there's an example for circuit breaker. I don't go through that. It's super easy to find in the internet. I referenced an article where I also go into stateful retrying and as an idea. But this is something, if you're interested, you can dive deeper into later on. So to go back to the title, like loosely or lousily coupled, again, domain coupling doesn't go away, right? This is really important, more important. It sounds so obvious, but in a lot of discussions, it sounds like we can simply avoid coupling. No, that would be a weird application, right? We can remove probably deployment coupling, and we should remove implementation coupling, and we can manage temporal coupling. And that's actually where we have the most control, like these two in a way. Cool. Quick takeaways. Know the communication styles and the collaboration styles. They're not the same. I know I repeat myself, but this is the one and only message which I think is really super important to have top of mind. You can get rid of temporal coupling with messaging, asynchronous communication, if you can handle it. You will need, and that's also important, long-running capabilities. That's why I'm looking so much into these topics, because I really think long-running capabilities, like think workflow engine, can really help you out there. Yeah, domain coupling does not go away. If you want to learn more, I said that early on, you can always have a look in the book. And that's all I have for the moment. I will check. So first of all, thank you. This is normally where you get the clapping. And if you're in the real room, I kind of miss that a little bit. But anyhow, I hear clapping in my head. And we can go to the Q&A, and I will check the, oh, I get clapping in the chat. That's awesome. Thank you, Thomas. Blah, blah, blah. If you have any questions, you can type them in the chat, but I'm also happy if you want to unmute yourself and ask any question. I mean, that's also super possible. Let's see if I missed something in the chat. Okay, I got a remark on the 200 of the pizza, which is actually okay, because the pizza place normally just not only acknowledges like we got it, but they also give you a real feedback of might take 20 minutes. I do agree. So then 200 is okay. Yeah. Oh, to make sure order of messages in asynchronous communication. Okay, that's a that's another own talk. So typically, if you use messaging, and that's one of the complexities, for example, messages might be out of order, and there are ways of controlling certain sequences, or probably also technology, like just to name the most prominent. If you go for Kafka, for example, they guarantee a sequence because they're kind of a log, not a messaging system. But in general, what I would try to do actually is to design my application in a way that I don't rely on the sequence, on the order of the messages, which is not always easy, I agree, but you can make a lot of effort of doing that. So a prime example I have in some other slides is you charge something on a credit card and then you need to roll it back, which means you cancel that charge. If these messages are out of order, you get the cancellation first, and then you get the real charge as a service provider. So you could actually build the service provider in a way that it can still handle these messages well, right? It's not always easy, I agree, but you get to a much more robust system because you don't make too many assumptions on what the infrastructure can do for you. And that's kind of the trend, the direction we're moving into. Don't make too much assumptions on the infrastructure because that limits you in what you can do, which is, again, only true to some extent. So of course, if you use Kafka and you have certain features in there, I mean, you can probably use them, but I still would at least think about that. Can I build my application without relying on the sequence? When and where will the slides be available? This is one of the most important questions, like always. I will put them on my slide share. So if you search for my name and slide share, or probably search for my name, you should find my homepage there. I can put my homepage in the chat here. There you go. And there my slide share is linked. And I still have to check if the latest version of the slides is already on there. But if not, I make sure it will, like later. So any other questions? How do we solve distributed transactions problems? Yeah, I mean, that's like transactions. As I said, it's one of my favorite topics. I have an own talk on that. I called it Lost in Transaction. So that's also linked on my homepage. And there, it feels bad to always refer to what I've written, but there's also a chapter in there. But you basically have a couple of strategies to resolve inconsistencies that can exist in distributed systems. So one is you can ignore it. It sounds weird, but very often that's a solution. Just ignore it. You can live with this inconsistency from a business level. The second is you basically go back to a consistent state eventually, and very often that involves like either a saga pattern. So that's kind of the idea. I think there's somewhere an example in here. Somewhere down the road. I have to watch the time. Yeah. So for example, okay, sorry, that takes a while to get there. Like also, like we had a quick look at process engines earlier on, workflow engines. So you could model a process where you say, hey, I did this in the past, and whenever this fails, right, I define the kind of the compensating activity, the undo. Right? That's kind of a second thing. You could also do a reconciliation job, for example, like running once a month, removing inconsistencies. It really depends on the problem, like always. And one thing I like this, Martin Kleppmann is great. He wrote a super good book on O'Reilly, which is called too early morning here. How was that called? Data intensive applications, I think. Great book. And he goes into, okay, because you don't have transactions in microservices. Within one microservice, not cross. Then you can either do compensating things, that's what I just showed, or apologies, also like this. This is kind of the overbooking a flight example. So you don't fix the inconsistency right away. You wait for the effect to happen, for somebody to complain in a way, and then you apologize and fix it then. Okay. Can async communication be used in chat application? Yes, 100%, of course. Why not? It's probably like that in most of the applications. Are we free to email you with questions? Of course. No, I tried to make that clear earlier on. So if you have any questions, just shoot me an email. This is where you can reach me. I'm also happy, of course, if you connect on LinkedIn or if you tweet about me, only good things. Okay. And I think we have to come to an end for the Q&A. Awesome. There's a longer question for Marcel. What I would suggest is, if you have more questions, send me an email or ping me on LinkedIn or whatever. Thank you so much for joining this. I hope you have a great day, like a remaining day in JCon today. It's only day 2, so there are a lot of things still to learn. Thank you so much. See you around.